Hello everyone, this is a video solution to the question 2 in tutorial 7, which is about the first law of thermodynamics in open system. So if you read this question, you will find that it's quite a long question and you will find a lot of information. All these variables have been given to you. Okay, so what I recommend you is that while reading this long question, you can just make a list of all the variables which have been given. Okay, so then later you're going to use these variables in your equation. So I'm just going to make a list first of all. Okay, when we read that, we just read it a little bit slowly, try to get all the essential information in this question. So you can see here air, first of all, so we know that the working fluid, okay, is air. So we have two kinds of working fluid, air or the water and the steam system, okay, and it's flowing at kilogram per second. From the unit, you know that's m dot, okay, so that's not a fixed mass. We know that must be an open system. So m dot, so I can just write, make a list here, okay, m dot is equal to 3.18 kilogram per second. So it's a good habit actually when you write down the figure, at the same time write down the unit. Okay, this will make you aware that if you are writing a SI-based unit or not. It's compressed under steady state conditions. So that's why we can use that equation. What do we call that? So it's called a steady state energy equation. Okay, given that the specific enthalpy before the compression, so it's before the compression and it's talking about a specific enthalpy. So that's specific enthalpy. So before, okay, that's inlet. We use 1 for inlet, okay, which is 292.15 kilojoule per kilogram. The final specific, so that's end state, specific enthalpy. And the heat, so we know the heat is transferred from the air to the surroundings. Okay, so when we write the heat, okay, we need to think about two things. Okay, first of all, the unit. So this unit means that kilojoule per kilogram. Okay, so the heat transfer, the total heat transfer must be in the unit of kilojoule. However, if it's kilojoule per kilogram, means that the unit itself, okay, give us some information that the heat is in a specific heat. Okay, so that's lowercase q, specific, which is 39.8 kilojoule per kilogram. Also, we need to think about the sign for that heat transfer. Okay, so you can see here, heat is transferred from the air, so basically from the system to the surroundings. Okay, so this is the opposite way. If you comparing with how engine is working, because in the engine, the heat is transferred into that system. So it's a different way, and they must have a negative value. Okay, so here you need to be very careful that the Q has got a negative sign, right? And then you need to determine the power input to the compressor. So you need to calculate the work done. Power input. And you may ignore changes in kinetic and potential energies. So these two are 0. So for all the open system problems, actually, if we have a look at the formula sheet, you will notice that we have not formula sheet. We actually have only 2 equations. Okay, so this is called the first law of thermodynamics in open system. So for any open system questions, we will definitely need that equation. So this will be the long equation. Okay, and then this one has been used in the question 1, and now we're just going to write that equation down. So first of all, I would just recommend you just to write that down, copy that down. So we have Q dot, right, subtract W dot is equal to M dot H2 subtract H1 C2 square C1 square and G Z2 subtract Z1. So you just copy, basically just copy this long equation down, and then we have a look at the this particular question to see how can we simplify this long equation. Okay, so in this case, we know that ignore changes in kinetic and potential energy. It basically means that these two terms, these two terms can be just ignored. Okay, and then long equation can be further simplified as Q subtract W M dot H2 subtract H1. Okay, then we just compare, you have got a list already here. Okay, so we just tick inside this equation, we just tick what have been given and what we are going to solve. So we know Q, right? We know lowercase q, okay? So this is a capital Q, okay? And we know the H2, H1 all have been given, right? So what we need to is calculate the W here. So this actually is W dot, okay, W dot. So now just rearrange this equation to get W dot. So W dot, you can move to the right hand side, then you change the negative sign to positive sign, and you move this bit to the left, okay? So that's Q dot subtract M dot H2 subtract H1. Okay, Q dot, we actually don't know Q dot, however we know the smaller, okay, the lowercase q dot, right? So actually the capital Q can be written as M dot times Q subtract M dot H2 subtract H1. So we know M dot, which is 3.18 times the lowercase q. Okay, so this is a negative value, right? Subtract M dot again, H2, H1. So we can check from here. H2 subtract H1. So now you'll be able to calculate, okay, using your calculator, and finally we get is minus 500.1. Okay, so you can also double check the unit in here, right? So if we have a look at here, M dot has got kilogram per second, M dot. The lowercase q has got kilojoule per kilogram, kilojoule per kilogram. Okay, so kilogram cancelled, so that's a kilojoule per second, which is just in kilowatt, right? And also here for H, we've got kilojoule per kilogram as well, M dot kilogram per second. So again, this is kilowatt as well. So you just make a double check, double check these two terms are exactly in the same unit. So if they are in the same unit, then you don't need to make any conversion here. So we know that we use kilowatts, subtract kilowatts, and finally we still get kilowatts here. Okay, so we get a negative sign. So negative sign for the work just means that, okay, so it's, if we get a negative, means this is opposite way of how engine is working. Engine is outputting work, so it's doing work to the surroundings. If we get a negative, it means that that's opposite way. So the surroundings, so the work is done to the system, okay? And this is exactly how a compressor is working, because you can see this is a compressor, okay? So compressor is the other way of working as a turbine. So turbine is outputting work, And for a compressor, you do need to input work for a compressor to work. So you need to input the electricity for the compressor to work. Means that this minus sign is actually correct here.